Okay, I am going to talk about 16.3. Fructose and galactose are converted into glycolytic intermediates. And on the left side of this screen, it talks about table sugar and lactose. Sucrose is table sugar, and it's a disaccharide that's made up of fructose and glucose. Lactose is a disaccharide that is found in milk, and it is made up of galactose and glucose. Another common disaccharide is maltose, and it's made up of two glucoses. So notice that each of these common disaccharides all have one glucose, and then they either have fructose or galactose or two glucoses. So we're going to look at the monosaccharides fructose and galactose and see how they fit in glycolysis. On the right side of the screen, at the top, you can see glucose. It's converted into glucose 1-phosphate, and then glucose 6-phosphate, and then fructose 6-phosphate, on down to pyruvate, and that's the pathway of glycolysis. So that answers how glucose enters metabolism. What about fructose and galactose? Well, fructose in the liver can be, through several steps, converted into dihydroxyacetone phosphate and glyceraldehyde 3-phosphate, and those two are glycolytic intermediates as well. In most tissues, fructose, including adipose tissue, fructose is converted into fructose 6-phosphate in one step. And I'm going to show you that. I'm also going to start a timer that will stop in about 6 minutes, and I'll stop this video lecture at that time. So let's look at fructose going to fructose 6-phosphate. So fructose can be changed in one step into fructose 6-phosphate by phosphorylating the fructose at the 6th carbon. And you're going to see a pattern, which is an ATP is used in the first step of modifying a metabolic intermediate to phosphorylate it, and that's almost always the first step. And the types of enzymes that phosphorylate are called kinases. And you remember in glycolysis, the first enzyme is hexokinase, and that phosphorylates glucose to glucose 6-phosphate. Well, hexokinase can also bind to fructose and phosphorylate it on the 6th carbon to make fructose 6-phosphate. So that's pretty interesting that the same enzyme can bind to two different substrates and phosphorylate them. Okay, so moving on to talk about the galactose and how it moves into the glycolysis. We'll look at glycolysis, and I'm going to use a red pen for all of the pathways of glycolysis. So glucose is our first molecule, and there's a one-way reaction catalyzed by hexokinase, and this of course requires an ATP, and we get glucose 6-phosphate, and glucose 6-phosphate is in equilibrium with fructose 6-phosphate, and there's an isomerase that catalyzes that reaction. The next reaction, the third reaction of glycolysis, is catalyzed by another kinase, and this is phosphofructokinase. Fructokinase, which we abbreviate PFK. And of course, it also needs an ATP to do that phosphorylation. So now the fructose has two phosphoryl groups on it. So it's fructose 1,6-bisphosphate. And at that point, it splits into two, and that's the aldolase. So as soon as it gets two phosphoryl groups on it, it gets split into two molecules, the dihydroxyacetone phosphate and the glyceraldehyde 3-phosphate. And so those continue on. You guys know how that works. I'm going to stop and show you the branch point here at glucose 6-phosphate. Glucose 6-phosphate is in equilibrium with glucose 1-phosphate, and this is the pathway to glycogen. Oh boy, let me get my eraser out. try that again. And, oh, I also want to use a different color. So I'll erase that and we'll use black. So glycogen is a storage form of glucose. It's just polyglucose. It's many glucoses all hooked together. And the pathway to glycogen starts at glucose 6-phosphate, and we have a mutase that changes where the phosphoryl group is. Don't know what I did. I touched something that I wasn't supposed to touch. So we have glucose 1-phosphate instead of glucose 6-phosphate. Now glucose 1-phosphate is then activated, and it's activated to what we call UDP glucose. And UDP glucose is, UDP is just like an ADP, except for instead of having an adenine, it's got a uracil with 2 phosphates on it. And that is a small molecule that's attached to the glucose, and the UDP is like a good leaving group. So we can think of glucose as being activated. A reaction like an SN2 reaction can happen to it. And in order to get the UDP on, the glucose 1-phosphate reacts with a UTP. So the UTP loses a phosphoryl group, and the rest of it attaches to the glucose 1-phosphate. And my goodness, I keep on touching this and messing it up. Yeah, so then UDP glucose, which is activated glucose, so the good leaving group, reacts with a growing glycogen molecule. So we've got glycogen, oh, I better get my eraser out, get that spelled right. Glycogen, and this is a glycogen with N glucoses. And the UDP glucose reacts with that to make a glycogen with N+1. And of course, the UDP comes off and goes to waste when that happens. Well, maybe it goes to waste. Maybe something good happens to it. Okay, so here's where the galactose comes in. Galactose uses UDP glucose and the glucose 1-phosphate to get galactose into the glucose 6-phosphate. And my timer is done, so I need to quit, and I'll finish this in the next video.